Hi, this is Merlin Tronica from 4th year CRC. Today we're going to see about our fifth exercise in data mining, which is about support vector machine. Support vector machine is a supervised learning model with associated learning algorithms that analyzes data used for classification and regression analysis. So what we're going to do is we're going to do a model-based classification with our RapidMiner. I have a data set from the samples. I'm going to choose this Sona dataset and I have retrieved and dragged it here. Once after dragging this Sona dataset into your drag area, I'm going to choose the next operator for this operation, that is the support vector machine. I'm going to choose this, and once after choosing this, I'm going to connect these two operators and with the result. Once after doing all these processes, I'm going in for run. After running, I'm getting a kernel model with some particular values. This kernel model is actually linear and it has a total number of support vectors and bias offset. Here the values vary from 0 and -0. This is because it has a particular threshold and the values accordingly have arranged itself and gives the value for positive and for negative attributes. Once after getting this kernel model, I'm going back to my design and I'm going to show how we get the exact XVM. So I'm going in for validation and I'm choosing this cross validation process. This cross-validation process is an operator which is used to estimate the statistical performance of a particular data set. So once after dragging this validation operator, I'm going to click it, and within this validation operator we have two sessions, and one is for training and one is for testing. And within this training session, I'm going to have the operator as SVM, the support vector machine. And in the testing process, I'm going to have this apply model and the performance operator. Once after choosing all the operators, I'm going to go in for the connections. The required connections are made. Yes. Now once after doing this connections, I'm going to connect these two operators. And the other efficient thing about the SVM model is that it has many parameters lists here, and according to these parameters the dataset is going to be designed, and with these values, like for kernel type, we can choose anything of this classifications from radical and polynomial, neural, any such thing, and the C value can also be changed accordingly. If the dataset which you have is more in more quantity or in more size, then you can choose a greater C value, or you have a dataset of about 10 to 15 informations, then your C value can be less. So in accordance with the dataset, the C value can be changed accordingly. And once after doing all these connection processes and the operator drag-ins, then I'm going in for the run. So here is my performance vector. The performance vector shows me the performance of the datasets which I have Basically, the sonar dataset is about the rocks and mines, and it gives me the accuracy for each classifications like 76.29 and 81.08. Then I have this example set which has undergone all the processes like validation and applying models. And once after doing all these, I've checked the accuracy. My accuracy is about 78.85, which is real good, but it can be increased or decreased by the performances of the C value. By increasing the C value, you can increase the accuracy of your dataset. So this is all about the SVM model for the data mining process. Thank you.